Hello, and welcome to How Cisco Reduces Air Pollution with a Digital Twin created using Python, LoRa, Google Cloud, and InfluxDB. Today's webinar is sponsored by Influx Data and Cisco and produced by Actual Tech Media. My name is Scott Becker. I'm with Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now next, in your handout section of the webinar control panel, you'll find that we're offering several resources. And I'd especially like to call your attention to a pair of PDFs, one on why time series matters and one on InfluxDB edge data replication. There's also a link to a free trial of InfluxDB Cloud. Also in there, you'll find links to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Events Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Now, at the end of this webinar, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found also in your handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. So it's my pleasure to introduce you to our presenter today. We have Ehsan Fazel, who's a systems architect with Cisco. Ehsan, welcome. Thanks for joining us.
Thanks, Scott, and thanks to audiences joining to listen to this webinar. Is a case study about one of the projects that I have been involved and leading on a technical side to help our customers to actually reduce the impact of the construction site, roadway construction site, to be more precise in terms of the environmental impact. With that said, I start with a bio. I have had experience in building various IT and OT solutions throughout many years through the use of diverse sets of technology where we have specific challenges. So I've been building networks for a very long time. And I put those strengths and my learning curve and try to extract data from systems such as IoT systems that are really challenging and hard to connect and extract data from them. And not only the data itself matters, but also just transport them by itself, but also analyze them in very detail to unpack the data inside of them to be able to present meaningful data to our customers. So these are the things that I've been doing throughout the years. At a personal level, I love cycling as well as sharing what I learn, and here is an example of it. In a spare time, I teach Python to associates or new entrants into Cisco as well, and I'm presenting you from Cambridge in England. So with that said, as I mentioned, I've been working in a number of different industries. I worked in the transportation, utilities, manufacturing, and smart cities. I have to say, working and delivering IT solution to these types of environments nowadays, they're called OT solution or operational technologies. They're extremely challenges, just not only just technologically, but also you're dealing with the diverse sets of data. But what do they have in common is actually they share the same challenges in terms of the harsh environments that you have to connect the unconnected and extract data from very specific devices that are really hard to actually tap into to be able to extract data. And the data that we have, most of the time, they're very abnormal, encrypted, or they follow a very specific pattern. But on this presentation is one of many projects that I have done. I'm sharing exactly one of the use cases, how I have delivered one of the very specific use cases. The project's actually itself called iTrace, and fundamentally, the projects came about in order to address the traceability of a data, or being able to deliver the data that actually is authentic, it's traceable and trustworthy, such that it can be used further down the chain for operational use cases. So essentially, we extract data from sensors that are diverse in nature, and then we collect data, we consume them. Also, we use some machine learning techniques to identify the abnormalities, the outliers, or the other data that we need to be care about or handle in a specific ways. Also, we had distributed networks or sensors have been distributed across a range of different environments and geographically dispersed as well. The project's obviously led by Cisco, but also we partnered with ecosystem of others, the likes of Senson, that develop algorithms, specific machine learning algorithm to be able to detect the outliers and anomalies. We also work with BT, who provide us digital twin capabilities as well as blockchain in order to make data immutable. We also engaged with Warwick University in order to analyze the system or design the system as a whole to ensuring authenticity of data. And also we work with Costain, who are one of the construction companies that building the roadways. And they allowed us to install our sensor and work with us to install the sensor. And we have been in contact with the site manager in order to help them deliver the construction activities more efficiently. So I start this by the architecture of the system as a whole. Again, iTrace is a big project. We have delivered a number of use cases. And this very specific one actually starting with construction, but fundamentally the process is the same. So we have the devices on the left side that either sensors or devices generating data for us. And then we have the IoT gateway, where majority of the operation happens in terms of connecting the devices that are hard or very difficult to connect, which is the last mile. And we do have edge compute capabilities. We're ingesting data at the very edge and then process data at the very edge before we process them any further. We examine data in the very details. And then further down the chain, then we analyze, authenticate the data, ensuring data are within the acceptable range that we wanted. Once we're happy with that, then we take a copy and deposit data into InfluxDB for the initial consumption. Along with that, take a replica for digital twin capabilities, as well as blockchain use cases, and also cybersecurity analysis. Also, we take a copy for maintenance perspective and ensuring we can actually look into the data itself and maintaining and operating the system as a whole and updating the code or make changes as and when it is necessary. So what are the time series databases? Time series databases is something that, as name suggests, they are essentially indexed based on time. So when you have your data indexed with certain format, then obviously then you can do a lot more with them. You can do a lot more with more efficiency. So essentially, what do they mean is, I'll give you a few examples such as market data, network data, network telemetry data, or events or click streaming, and in our case, the IoT sensors or temperature sensors, so on and so forth. So we're measuring the device, the parameters from the device over time, and we store them, and we call them time series databases in effect. So if we compare them against other available databases that most widely known and most widely adopted in the industry, like relational databases, document-based or search-based, what time series databases are different because they are indexed in a certain way, then that allows us to apply lifecycle management, retrieval of the data, store the data, transport the data a lot more efficiently. When you can do that more efficiently, then obviously the cost is reduced. Therefore, you can pass the cost to the customer, and you can achieve a lot more by having data in the right order, in the right format stored inside of the time series databases. Obviously, in our case, we choose to use InfluxDB. So about the project itself, it's about building a dual carriageway in the southwest of England, and the site has got some sensitivity in a number of respects. First, their site is archaeological interest, as well as the environment ecologically is fragile, and there has been a lot of interest and sensitivity around it. We therefore needs to provide the right means to the construction company so they can carry the activities as efficiently as they can. And the focus we have, we focus on two main elements. One was the plant efficiency, ensuring when the excavator or the other machineries that are operating, they're operating in the most efficient way. And a second is about what kind of activities or construction activities could be performed at what time, or what kind of a specific climatic information. And by the way, we have been working with a site. We're providing real-time data in order to be able to make the informed decision. So let's see, what is it we're actually measuring? We're measuring the noise, the environment. On the top right corner, there's a picture of a noise sensor. It's fairly small, but it measures the noise. And there are two reasons. One is the local authorities are interested to see if the amount of noise is generated is within the acceptable limit throughout the day and night. And also if there are hazards that the construction workers need to be aware of, such as wearing the safety gear, so on and so forth. We also measure the climatic data, and these data are being fed into the site directly in a live format. The air quality is important for a number of reasons. The first is actually informing the construction workers if the amount of SO2 level or NO2 level or particle matters that they are hazardous, they are aware of it, so they can take the appropriate measure in order to address that. Also, we're reporting these to local authorities as well. We're also measuring vibration on the construction plants, as and that's going to tell us whether the engine is on, whether the engine is off, or idling. And we have a GPS data that we have magnetic GPS attached to some of those devices, and tell us whereabout they are, and we keep history of whereabout these constructions are and construction machines are, and what path do they take. And these are vital information to be able to provide a KPI, which means the ratio of the engine is been on versus the move, and when they're moving, whereabouts are they going, and what path do they take. Is the path the most optimized one, or whether they're merging into the traffic where they shouldn't. And that's vital information for us to be able to feed back into the site itself. So these are the parameters essentially that we're measuring, collecting data, authenticate the data, making sure they are preserved and handled in the right way, and is being shared with the right audiences. So in order to do that, we had a few challenges. As a starting point, we had limited electricity. Although in the picture, if you pay very detailed attention, there's a transformer, but in reality, we did not have connectivity to power grid. So the entire site has been relying on wind turbine as well as a solar panel. And there's a battery, and limited electricity has been made available to us in order to be able to power up our equipment. We also had a very patchy 4G coverage. In fact, we didn't know what to expect. The site is extremely remote, and we had to post the equipment and hoping for the best that everything is going to just have a 4G connectivity, electricity, etc. Also, we had to measure diverse sets of parameters on site. And then last but not least, once we have the data, how to share and where to share the data and how to do that in a live format. So the limited electricity has been addressed by our equipment, in fact, consume very little data, just 9 watts of power. So that means we had a very low barrier to ask for a little bit of power from the site where it's actually extremely limited. The other benefit in our case were not so applicable, but other locations might be, where you need to host that equipment inside of an enclosure to protect it against humidity and rain. On those occasions, then if the power consumption or the heat dissipation from the enclosure needs to be more than what is being generated from the equipment itself. So that means 9 watts allows you to have a very small footprint. The patchy 4G coverage is being addressed by, actually, we picked one of the operators, EE in our case. However, the SIM wasn't a normal SIM; it was a roaming SIM. And what the roaming SIM means, that it can talk to many other providers as well. And the way it chooses to talk to which roaming provider is very, very intelligent. So as soon as the router comes online and it can detect a 4G signal, it will check for the signal strength and then build connection into the most with the strongest signal, and then try a few others as well. Once it's tried, it will measure the latency into whichever 4G provider has got better quality link to us, and everything just inside of the router happens automatically as part of a built-in feature. So we had one SIM, one roaming SIM that could talk to multiple different providers, and we really didn't need to do much. We just knew that we're going to get good coverage, and indeed we didn't have much of a problem. Also, there are some other techniques inside of the Influx that I take advantage in order to make sure, in case the link goes down or there are other problems, data is not lost, but also stored and then forwarded when it comes back online. We use an open source and a vendor for our sensors based on LoRaWAN, which I'll double click later on. And that provide us a wide range of measurement across different sets of requirements that I mentioned earlier. We also had to share live data with the users. I'll get a screenshot at the end, where essentially we have data from InfluxDB dashboard directly. So pretty much no development in order to extract data and make sense of data, because I could literally share a link with the consumer of a data. And then we had a mobile-friendly version of that available to us, so they could simply use it. So what's the architecture of the system as a whole? I start this by the sensors on the left. In our use case, we had the LoRaWAN sensor broadcasting data. This sensor needs to go through the onboarding process, time synchronization, so on and so forth inside the LoRaWAN gateway. Once we ensure data or the sensor is a legitimate sensor and belong to us based on certain parameters and has gone through a staging, then the sensors could have been deployed, located, whether attached to magnetic into equipment or whatever the case may be, or hang on a fence and powered up by solar panel. And then we had the edge computing capability. In our case, you use Cisco IR 1101, where it does have 4G connectivity, serial connectivity, edge computing capability. Is a versatile platform for us to be able to cater for all kinds of requirements that we had. We obviously had the internet as our transport. And since that 4G SIM card come with a private address, it's not reachable. Obviously, we still need to access the environment as well. So I had to run a virtual gateway inside of the Google Cloud platform so that it could be used an anchor tenant in order to be able to get into the system itself and could be secured. So essentially, the system sits behind an enclosed system, or almost an air gap system, if you like. We had a management platform where I could VPN into the system for updating, patching, or other maintenance use cases. Also, we're posting data in various databases that I mentioned at the beginning as well for visualization, consumption of a data, digital twin, or other use cases that we had in there. So the system is fairly simple. As you can follow it, data comes from the sensors. Just to recap this, goes through the LoRaWAN gateway, goes into the secondary gateway, if you like, where we do majority of the processing. And from there, we post data where it needs to get to. So what about the data flow? So I mentioned about the physicality, but how the data flow actually look like. So I mentioned sensor sends data over the air, and then we receive data actually on base 64, which is kind of an encoded data. So they are not readable by someone who might intercept data over the air. But it's base 64, and within run a container inside of the router itself, a Docker container, standard build, could be ported into other computing platform as well. But obviously, we took advantage of those capability inside of our existing platform itself, and essentially act as an API gateway. So run a Flask Python based on a Flask that is a gateway. API gateway that is listening to the post that comes from the LoRaWAN gateway. We then do the basic checks, if you like, in terms of where the data comes from, with a certain base of the data itself. And then once we get there, then we start parsing the data, which I have a sample data. I know that may go into the very details. I'm hoping that's going to be meeting everybody's expectation in this webinar, and then validate the payload itself. Throughout the process, I'll log every single piece of information that I have. One of the example is, as soon as I receive encoded data, I take a copy and take a replica and copy into the Google Cloud storage for future repository. Validate the data. Obviously, if the data validation passed or failed, take a copy of it, or making sure that has been logged. And eventually, once all of that has been passed, then deposit the data in a normalized format into InfluxDB, and then from there, data is available to the consumer of the data. So with that, going through a bit of decoding and how the process looking like in a very detail. To start with, because we wanted to cater for all kinds of possibility of system being attacked, deliberately, if data arrives in the gateway and doesn't even have an API key, I just take a copy of the data. I won't process it. I just copy of the data and deposit it on Google Cloud Storage. If API key passed, then I'll start parsing data into the next stage. Check into a JSON file, JSON object, if you like, where I got a sample on a page in here that tells you number of parameters that are being sent to us. And then once I've got all of that data that meets certain criteria that I'm expecting, certain parameters are there, data could be parsed. I do have actually the payload itself and meet certain criteria. Then I'll start decoding of the data itself, where data comes again in a hex format that needs to slice and dice data based on the specific instruction that is being supplied by sensor specific. And then Now I have data such as humidity, vibration sensor, noise sensor, other climatic information as well. And then from that point onwards, then I have a data that is consumable. So next one down, in terms of tips and tricks, obviously, why did I choose time series databases? Simply because I could index my data based on time, and I had data in that format. And the most efficient uh, way of storing data was actually taking advantage of time series databases. I also used InfluxDB on the cloud version because obviously that has very lower barrier to entry. I did not need to maintain any infrastructure. I could simply take data and store data and then start consuming data without the need to maintain any physical infrastructure unless I have to. So I also use the available Python SDK. So entire stack runs on Python, if you like. So I did not need to learn any other languages or integrate this with other systems. Pretty much the entire system could have been deployed by just one language, which makes it a lot easier to maintain the code, update the code, and other activities that I needed to do. But just remember, one of the things is connecting the unconnected remains a challenge unless you have a good solution for it. And working at Cisco, I've been blessed with an array of options that I can pick and choose which one works best for specific requirements. And it's something that you need to bear in mind if you're looking to build similar systems. Um, yeah, monitoring the application and infrastructure is one of the key elements as well. As I mentioned, I'm running a Flask server and it has to be up and running all the time. So far, for the past couple of months or nearly a year, I would say, the system has been operating without any interruption from the gateway itself, if you like, and the application that has been built resiliently. One other thing is actually data validation. It's very important to validate data because, and do it at the early stage, as early as you can. Have some form of mechanism, otherwise data that you have could have been deviate from what you would expect. So ensuring you have some built-in features functionality inside of the code that can actually cater for that. The other thing is obviously if you're looking to run your code, making sure you can handle exceptions really well and build for ultimate cases that anything could actually go wrong. And then that has been actually catered inside of the code itself. So that's one of the things by writing a robust test cases would help you being able to write more quality application. So on the right is actually one of the examples that kind of simply I just write a decoder for a very specific sensor, and the Influx SDK is just requires to call that very specific decoder function, and we had a data back, and then we could just simply write it. So that would help me write a code that is reusable, that didn't need to rewrite the code multiple places. So here is a few screenshots from the result of the system, if you like. So I have to say it was very easy to set up. As soon as you set up your account, you're there to start writing your data on your database. Very easy to do, and you get a very detailed instruction how to do it. And once you have your data, it's extremely easy to present it. You can create your own dashboard literally with a few clicks. And on the right side, we have a mobile version of it as well. You could just change the time window and other kind of other things you want to show to your customer very comfortably without need to do tons of development work. So you could just share a link and then you post the link to the consumer of the data, and they have a copy of the live data as they go along. Data visualization explorer is really good. As I mentioned, the Python SDK has helped me immensely that I did not need to integrate with other system or take advantage of another plugin. So I just had to write and use the Python SDK easily. One of the things was, I wouldn't say it's a bit of challenge, but working with a UI to start with, I had to try a few things, but eventually I get there. But once you create a shared link with your customer, for example, you don't get a chance to change the time window. And these are the features I guess will come at some point in the future. That was really helpful. And the other thing was the documentation. It's a very minor item. As a developer, I have to figure out how to find what I needed to do. But I would say some area of improvement would make it a lot easier for me as a developer. With that in mind, here's my contact details. And I salute you in staying on the call, and I look forward to see what else you will be able to do with InfluxDB. With that, I hand it back to Scott if there are any questions that I need to answer.
Yeah. So that was a great use case example. It's so helpful to see how all those technologies are used together. In the solution there that you had, and for such a complex project. I also really was interested in how you were overcoming the challenges of limited electricity and patchy 4G coverage. That was fascinating. But one of the first things is, I'm really interested in going into a little bit more of some of the reasons that you guys went with a time series database instead of a relational database. And sort of before we get to that, for those of us who haven't brushed up on time series databases versus relational in a while, what's sort of the key difference in the way, those two databases, structure information?
Yeah, obviously, the indexing is a key. When you have time, then you have a clear index that you can work against. You can store them as a sequential basis, and it's just not about storing data, but also retrieval as well as life cycle of the data. So you can query data a lot faster. You can recycle or purge data a lot easier when you have it on a time series. Obviously, querying data becomes a lot faster, and especially in InfluxDB itself, you can write data on an asynchronous fashion as well. If you go with a relational or other SQL type databases, obviously they are extremely persistent and transactional based in nature. Obviously, that's what they're there for, versus InfluxDB gives you the option to write data on an asynchronous fashion as well. So where we had like even patchy coverage, if the connection is lost, we could comfortably put data in a queue and then just flush the queue as soon as data become available, versus if I were to choose a SQL databases, they're extremely persistent and concurrencies matter, but in our case wasn't so much. So I had that flexibility, and that time series databases comes into play to help us to use databases in a right choose the right database that is built for what we want to do.
Gotcha. Okay. Yeah. So that's great. So I think that you've hit on sort of my next question there, which was, some of the specific advantages of a time series database for your project here over a relational database, and that's to do with that patchy coverage and asynchronous, inputs. Okay. Yeah. Any other advantages for this specific project of using a time series database like that?
I would just call the InfluxDB itself, because although you can get OpenTSDB, you have other time series databases, but the visualization aspect of it just immensely helped us to deliver value out of data at a very short period of time without the need to do development work, if you like. So what it means is you got your data deposited, off you go. You now have the value out of your data, versus otherwise you got to pull the data into a visualization platform, either build it ground up or whatever the case may well be, just get another plugin. But in Influx, you just get something straight out. Time to value is reduced. So that means Especially when you talk to your customers, they want a value quick, right? They want to see the result very quickly, and that brought tons of advantage to me, and I deployed it for other use cases as well, and that was exactly that. So customers just create a graph, put it on a dashboard on their operation center, and pretty much I haven't done development for the visualization side of it other than just, this is what I want. This is the query that I want to run to get what I need to get.
Gotcha. Hey, and so speaking of queries, how are you querying your data?
So we write it with Python SDK.
Okay.
We retrieve the query data from Python SDK for other use cases as well. Obviously, in our specific, we had Senson that I mentioned. They have been doing analysis on the data, detecting anomalies and outliers. And they've been using actually Python for the machine learning element of it. So they just literally pull off data. Obviously, there is Influx language, Influx QL as well, where it would speed up the process. And this is actually something we're looking to do in the future. Once data become the volume of data grow quite high, then that's when FluxQL comes into play, because it would work really efficiently. Today's Influx days, I believe, and I heard there are other advancements are coming down the line as well. So that's a timely question. But yeah, the number of ways you can query data, but that FluxQL is the way forward for the future, I would say. But we're early stages in our case.
Okay, great. And another question here, and you might have gotten into this a little bit on the last one, but are you using any sort of analytics service, or have you applied any AI to the data?
That's right. Majority of that work is done by Senson, and I can share what they have done. Obviously, there's certain things you can do, certain things you cannot do actually. For example, on the noise sensor, it's really hard to identify a pattern, because if someone's clapped next to the noise sensor, you can't predict it and you can't flag it as an anomaly because it did happen, right? Versus other things like temperature or humidity, particle matters less, but there has been very deep dive analysis or very detailed analysis, such as average range of or range of change on the temperature, if you like, over hundreds of thousands of data points. That gives you a pattern, as if sometimes you all of a sudden temperatures tell you 19, you get a data of 40. Obviously that's and drop back down, you realize actually that was an outlier. You can just put it straight out, right? You can filter
Right.
that or very quickly. So we did do on the post-processing element of it, but for the consumption of the data wasn't so much of a significant for us. But it's something, definitely, if you were to do it, probably you could create various training models of AI to analyze data. Once you analyzed it, you're happy, then you can put it on the secondary databases or Influx instances or other buckets to be able to say, this is the raw data. You may not want to present it directly to your consumer, but also once you post-process it with some latency, if you like, now I'm sharing more credible data. It's one of the things probably we will do for the future or the next projects that I'm going to do. But obviously, it's very important. I can see it's very critical, because you don't want to read data and just say computer said X, Y, Z, unless you have certain level of credibility behind your data. And if I were to expand on that, one of the things that we had to do, the sensors that we deployed are certified according to certain standards. Professional sensors, yeah, you can find sensors out there and tons of them, but the accuracy cannot be guaranteed, versus ours had certification. So if you were to build a reliable IoT system, it's very fundamental before you even want to consider any machine learning activities, because your data has to come from a credible source. you get the data, you then massage the data, parse it, and then go through the very details just to see if I read is what I'm expecting or within the acceptable range. It's something definitely evolving.
Interesting. Yeah. Okay. Next question here comes from Paul, who's asking, can Cisco's digital twin model and development process be adapted to addressing other related issues such as climate shifts, water pollution, food insecurity, etc.? I wonder what what other kind of projects you're doing, or what you guys have thought about applying it to.
Yeah, certainly. Actually, such as water treatment is one of them, is critical one that there's a lot of sensitivity around it, that there's a lot of regulations around it, where this was kind of a pilot project, but we're working with others in order to deploy similar systems where they have to rely a person to go to site to make changes onto the system. And now what we're looking to do is, once we've proven the credibility of data and authenticate data end to end, then specifically using blockchain and digital twin together, if you like, then that allows us to be able to making sure data at source, it is what it is at the destination, and being able not just to transport the data, but also check the payload itself. And that's an interesting area for myself as well. So water treatment is one of them, along with many other use cases that we're exploiting. And there are many projects inside of Cisco is going on. In fact, we do have innovation competition launching, and if there are specific challenges and solutions are out there, we're keen to hear about them.
Okay, great. Hey, in speaking of the stack that you were talking about today, with all the elements in it, did you, in addition to the challenges, from the project, like, the electricity and the Apache 4G, were there challenges and workarounds with the stack, just getting, those components to work together?
Yeah, a very good question. And it's often, I would say, most challenging part. The system that I built together is very much like a Lego model. So I pick and choose just about everything from different parts. And because it's never been easy working in an OT environment, you're not blessed with all the things you wish to have. So I had to build such as open source container, open source Python Flask framework as an example. The LoRaWAN gateway came from a vendor who could generate standard APIs that data could be ingested. You had to stitch all of them together, and then you had the 4G element. Me come from telecom background and networking. The networking element is the easiest part, and working with data, as soon as it becomes open source, then that becomes easy too. I'm more than happy to share codes with others, and if you look into Influx, you will see tons of open source code out there. But obviously, there are challenges, and once you do one or two projects similar to that, then it becomes very easy. And this is not the first. I think that's the fourth or fifth one. I've got a few others to come. So immediately you can just figure out how to do certain things and replicate code. I would say.
Gotcha. Okay. Well, I guess sort of a last question I wanted to ask you is, through this project and others, you've become sort of a power user of InfluxDB, I would imagine. You were talking about the Influx Data Days happening. Is there anything on the roadmap that you're really looking forward to, or things that you're coming up with InfluxDB that you're excited about?
Yeah, definitely. Obviously, Cisco has got tons of products that generate tons of data. And always my customers getting, right, I got data from this system on that system. And 9 out of 10 of them are the time series databases, right? Or time series in nature, or could be captured in a time series format that could actually be deposited on InfluxDB, given it's so easy to deploy and, again, very short time to value. That puts InfluxDB, I would say, in a very, very good spot, and easy for us to consume and deliver value to our customers. Mainly, I'll focus on Cisco's product, but obviously working with third parties and through innovation projects as well. Similar to that, we have a few on the radar that can't share just yet, but when the time comes, there are so exciting things I can see literally, right, my database is sorted. This is now Influx. Now need to go to the sequence of constructing a framework for a data and how to translate it into something that could be deployed onto Influx. So, yeah.
Okay. Well, Ehsan, thanks so much for coming on today. This has been a fascinating discussion, and really, it's always great to sort of roll your sleeves up and see how somebody has actually used the technologies, for a specific project. It's been really informative, and thanks for all the insights in the Q&A as well.
Thank you.
All right. So it looks like we're to our prize drawing phase. And so, before we get to that, I just do want to give everybody a quick reminder about the resources in the handout section. We're going to wrap up this webinar in just a second. So if you did want to grab either of those PDFs or the link there, just a quick reminder to do that. But we are at the $300 Amazon gift card prize drawing, and the winner of that gift card today is Michael Smilios from New Jersey. So congratulations to Michael. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Influx Data and Cisco for making this event possible. And thanks as always for attending and for your great questions. Have a great day.